In the autumn of 1918, death struck with such speed and ferocity that bodies piled in the streets before anyone understood what was happening. The Spanish flu didn't just sicken the weak, it tore through young, healthy adults and ended lives within hours. Entire towns fell silent, and for more than a century, the true origin of this nightmare remained one of medicine's greatest unsolved mysteries. Now, scientists have done the unthinkable. They've resurrected the virus's genetic blueprint from century-old lung tissue. What they uncovered is not what the history books told us, and it may rewrite everything we thought we knew about how pandemics begin. Despite its name, the Spanish flu didn't start in Spain. During World War I, most nations censored negative news to keep morale high. Spain, being neutral, reported openly on the outbreak. The world misinterpreted transparency as origin. In reality, the 1918 pandemic was already everywhere, sweeping across continents in 3 catastrophic waves, infecting a third of the global population and killing at least 50 million people, more than the war itself. Its deadliest mystery was its target, healthy adults in their 20s and 30s dying in staggering numbers, while some children and elderly survived. For decades, researchers struggled to pinpoint where the virus actually began. Some suspected the trenches of Europe, others the farms of Kansas, and still others believed it emerged somewhere in Asia. But without surviving samples, it was speculation, nothing more. That changed with a single discovery. Hidden deep inside a medical archive in Zurich, researchers found glass jars filled with preserved lung tissue from victims of the 1918 pandemic. The tissue had been stored in formalin and embedded in paraffin wax, an old pathology technique that unintentionally sealed fragments of viral RNA inside. Against all odds, pieces of the Spanish flu's genetic code had survived for over 100 years.
Using cutting-edge sequencing technology, scientists painstakingly pieced together the full genome from these microscopic remnants. For the first time, we had a complete genetic snapshot of the Spanish flu in continental Europe, captured at the height of the outbreak. This allowed researchers to compare it to earlier and later samples, revealing a story hidden in its genetic evolution. And what they found was unsettling. The Zurich genome didn't show a virus gradually adapting to humans. It showed a virus already highly optimized for infecting people from the very beginning. Key mutations in the hemagglutinin and polymerase genes, responsible for cell entry and viral replication, were already in place. These mutations closely resembled patterns seen in avian influenza, pointing not to a long evolutionary journey, but to a direct jump from birds to humans. Even more striking, the European samples were nearly identical to North American ones collected in 1918. That meant the virus was already a global traveler by the time it reached Switzerland, spreading faster than any medical system of the era could track. By comparing the Zurich genome with samples from Alaska, New York, and other regions, scientists constructed a phylogenetic tree, a family map of the virus. Every branch led back to a single ancestor that likely emerged in the Western Hemisphere in late 1917 or early 1918. The evidence aligned with historical reports from Kansas, where a deadly respiratory illness swept through soldiers at Camp Funston in March 1918. These soldiers were soon deployed to Europe, carrying the virus with them. Once in the cramped trenches and field hospitals of World War I, the pathogen exploded, riding troop ships, supply routes, and global trade across every continent. The Zurich genome confirmed it. Europe's earliest cases were not the start of the pandemic. They were already part of a worldwide outbreak set into motion weeks earlier. With this discovery, the opening chapter of the 1918 pandemic became clear. A bird flu virus, already surprisingly well adapted to humans, spilled over in North America. Soldiers, packed into barracks and troop trains, carried it across the nation and onto ships bound for Europe. In the chaos of war, with cramped trenches and poor sanitation, it spread unhindered. By the time civilian doctors recognized something was horribly wrong, the virus had already encircled the globe. For decades, historians debated Kansas, France, or China as the possible birthplace of the Spanish flu. But the resurrection of the virus's ancient RNA has tipped the scales decisively. The pandemic likely began with a direct avian spillover in North America, followed by an unprecedented global spread through wartime movement. But this discovery is more than a revelation about the past. It's a warning for the future. The 1918 flu shows how a virus can leap into humans already armed for rapid transmission. It shows how global travel, even in 1918, can transform a local spillover into a global catastrophe in weeks. And it uncovers the overlooked value of medical archives. Those forgotten jars of lung tissue sat unnoticed for a century, holding the answer to one of history's deadliest mysteries. How many more secrets lie hidden in old pathology collections around the world? After 100 years, the Spanish flu's true origin is no longer lost to time. Thanks to ancient viral RNA preserved in wax, we now know it most likely began as a bird virus in North America, already primed to infect humans before racing across the globe in 1918. This discovery rewrites pandemic history and reminds us that nature's deadliest threats can emerge suddenly, without warning. By unlocking the past, scientists aren't just solving mysteries, they're building tools to recognize the next pandemic before it's too late.
The reconstruction of the 1918 Spanish flu genome has rewritten the pandemic's origin story and transformed modern disease surveillance. It proves a virus can enter humans already highly adapted for rapid spread, without a long transition phase. This raises new concerns about direct avian spillovers and the speed at which future pandemics could ignite. The findings also highlight how global movement, even a century ago, accelerates viral spread beyond detection. Most importantly, the discovery shows the immense value of preserved medical samples, offering critical insight for predicting, monitoring, and preventing the next pandemic before it emerges. If you enjoyed this video, don't forget to like, subscribe, and share it with others who love exploring history through the lens of cutting-edge science. Every week, we uncover new discoveries that reshape our understanding of the past and our future. Join us next time for another story where ancient clues meet modern technology. Until then, stay curious and take care.